Hello and welcome to another podcast, Time for Tea with Andy. Coincidentally, I am joined by Andy Beale. So it's time for tea with two people. One thing I've never asked you, Andy, do you actually drink tea as well?
So, if you'd asked me that a year ago, I'd have said absolutely. I was a big tea drinker, but I've actually pivoted now to peppermint tea and completely removed caffeine from my diet. Um, so,
Wow. Okay,
yeah.
that's impressive. That sounds also very, very sophisticated. I like that. I like the vibe. I haven't quite got into peppermint tea regularly. I'm still the normal English breakfast most of the time, but I do occasionally enjoy peppermint. Anyway, the other really important question to ask you is that of ice cream. That's my other important starter question. So, do you have a favorite ice cream? Do you even eat ice cream?
Well, I do. I do eat ice cream. Always partaking in ice cream when we're at the beach. I'm always tempted and drawn by those fancy flavors, like salted caramel or a fudge brownie or something like this. But truth be told, you just can't beat a classic chocolate.
Wow, there you go. There you go. Yeah, I have to say, salted caramel and ginger are probably two of my favorites. But yeah, there you go. All right. Hey, thank you. Now we've established all of the core principles, we could get on to the tech. But before we do that, I'd like you just to introduce yourself briefly in a minute. Tell us where you are, what you do, what you've been doing, and what you're moving on to.
Absolutely. So, for those who don't know, me, Andy Beale, and formerly my last big role was chief engineer and head of innovation for BT Sports, one of the big sports broadcasters in the UK. Where I was responsible for all of the engineering, technology and operations from acquisition, outside broadcasts, and in our studio complex, contribution, through to our cloud providers and service providers, and then handing off to our distribution colleagues who are taking care of the last part of the chain. And in that role, responsible for a lot of our innovation and things breaking through. So, for example, Ultra HD, HDR, Dolby Atmos, things like Immersive 360, both first of all in 4K and then in 8K with tiled media, and all the other sort of immersive and customer focused objectives that we try to bring. Things like watch together during COVID, interactivity on the timeline with clips and all sorts of other things. That was me back then. I left in the summer and now working for myself, my own consultancy. We're helping other people with their challenges around technology and operations, particularly in the sports field, but also wider in the broadcast and media sector.
Wonderful. Hey, well, thank you again for joining us. It's great to have you. Great to have you here. So, what I wanted to do mainly is focus on latency in live production, and one of the reasons that's become even more of an important focus in recent times is because we have moved from a traditional all-on-site model, be that studio or events-based, to more and more what I call distributed production. The Americans call it REMI. Other people call it remote production. But the concept basically being you don't necessarily have the control and the storage and processing and the acquisition located in a common place, and there are quite a few benefits. But so first of all, is that a trend in terms of that distributed reduction? Is that a trend that you're seeing?
Yeah, absolutely we are. But there's a whole plethora of different models now in play, and each of those have different merits depending on the requirements and some of the constraints that each production may encounter, possibly to do with connectivity, possibly to do with the venue, possibly to do with availability of resources, people's location, etc., etc. And if we wind back and look at why remote production, why have we gone on this journey, right, as an industry? Well, there's a number of good reasons. People often start with the commercial point about cost, but in fact, truthfully, that's certainly in my experience the one that comes last in the list. There are sometimes commercial benefits, particularly with shared resources and things, but actually, if you're chasing that as your only driver, you won't really see the true benefits that this change brings. Things like sustainability, reducing the carbon footprint, either through travel on-prem, through lots of operators, or the equipment itself, or all the power required, lots of twin set, noisy, heavy duty generators, all this stuff that's traditional around production can be mitigated and start to be addressed through remote production. Accessibility is another really interesting one, both in terms of physical, but also social, economic, and in terms of people's accessibility to our industry. Traditionally, OBs are inhospitable. If you've got a physical accessibility problem, you're not going to be able to get into an outside broadcast truck, and so maybe this world was not available to you remote production centres are fully DDA compliant, and you can enjoy a full access and a career in a really much more accessible working environment. And then there's things like elasticity. So, particularly if we're talking about the sport environment, and particularly thinking about software-defined solutions where we can spin up and spin down infrastructure. Unlike the old world where we had to have a lot of hardware sat around for the top of our peak in our sports world, and maybe those top 50% of resources would get used for 10% of the time. In this computer-based world, in this software-defined world, we can spin up and down production environments, resources, facilities, production, processing, etc., in line with the production requirements, which is a much better fit commercially and technically and sustainability. So I think that's a huge benefit to your point. Going back to your question about what are the models, well, there are a few people still doing traditional outside broadcast, and there will always be use cases where that's required. I'm sure
Absolutely.
we're not going to see the Champions League final produced fully remote for a long time. Although having said that, UEFA embraced hybrid REMI for, as the Americans friends call it, for things like the Super Cup. So it has a place where they're very willing to accept it. Remote surface still has a place, and sometimes that's where you've got more constrained connectivity. You haven't got the bandwidth to get all of your signals off venue independently contributed, and so maybe in that world you can get a couple of signals out, maybe a reserve program, or maybe a clean feed, or maybe a couple of ISOs. But remote control of those surfaces is more appropriate. But more and more we see this trend towards actually connectivity being much more available, and so the ability to bring back all of your ISO signals and microphones and audio sources and fully produce that either in traditional hardware in a broadcast data center or a software-defined data center or in the cloud is now much more trending towards being the norm.
Yeah, I've seen several people that have really embraced this, centralizing the control and stuff and processing. I mean, the efficient use of people is a real thing. I see people saying that people can do 3 events a day rather than 1 event every 3 days. That's actually like a key thing. I think the other thing in terms of benefits that I've seen in several areas is because potentially the cost point can go down significantly. Depending on obviously the kind of technology you're using, that actually makes some events viable for a multi-camera production where it wasn't previously. So I think that's another
Yeah,
benefit there.
100% true. Tier 3 and below events that maybe were single camera previously or maximum 2 cameras perhaps, because of the ability now to contribute multiple sources back and have those efficiencies you've already mentioned, suddenly they're available for really interesting multi-camera production with extra production value things added, things like really good graphics, commentary, stuff that was out of the league potentially commercially of those budgets previously can now be fully attained. And if you look at, there's some really good content now being made in some of those leagues on probably distributed by YouTube, which is on a par with some of the sort of tier 3 stuff that's produced, dare I say, professionally. But I think that gap is closing, and it's democratizing access to really powerful tools which can make good production.
Yeah. Complete aside, but just going back to the sustainability, I was at a live production event at the weekend where they had eco hydrogen powering the whole event, which was really cool. Anyway, so that's the first time I've actually seen that at an event. So that's very good. Moving back to now we've set the scene in terms of like the benefits of why people are doing this. Obviously, the one thing that is added once you start splitting things apart physically is there's inherently some latency that you incur. And whilst we can do quite a few things technology wise to optimize the latency of the way we do things, there is the speed of light in fiber, which we can't do anything about. So there's the intrinsic 1 millisecond for every 200 kilometers that you can't renegotiate. But apart from that, other things can be optimized. We're working on that. But in terms of, I think within the latency issues or potential latency issues, I think there are some things that are uber critical and there are other things that are not so critical. So I wonder whether you can outline from your perspective the stuff that you think is absolutely vital in terms of being very, very tightly controlled, and other things that we're not so and not as critical as we may have thought.
Yeah, absolutely. And there are some things which really are essential as productions become messy. Production crews can get frustrated. Talent can get disorientated, and you really start to jeopardise the value of that production. Examples of this are things, for example, like audio IEMs. If we're having a chat, we need to be able to speak freely. I need to be able to hear myself if I've got in a really busy, stadium that's full of noise, fans cheering, and everything else. Music often blasting out, and so the ability for this fluid chat is so important. So the latency around here needs to be absolute maximum 20 milliseconds, but preferably a lot lower, and that can be harder in remote production. So a technique to mitigate that is often to do some audio pre-processing locally on site, and potentially do things like IEM mixes on venue still. They can be remote controlled, possibly, but certainly that local audio path should be taken care of locally to make sure that we have a really good experience from those people who are on camera or speaking potentially into commentary, for example. Return path latency, I think, is much more important, interestingly, which is confusing to some people, than the outbound. Outbound, we're really chasing quality. And although we'll come on to the synchronicity of those paths in a second, quality is potentially more important than latency, those pitch qualities, because they're going to get transmitted and go off to people's homes in HD and so on and so forth. That's a critical factor. The return path latency, so that a member of talent can talk over things like graphics, see replays, talk to stuff which is editorially relevant being added in the gallery, is much more important to be low latency. And of course, the quality doesn't have to be as high. As long as the graphics, for example, are legible, if they're super fast, that's really important. And then the director or producer can cue that member of talent in accordance with the graphics being put on in real time, and they can be talked to in a way which is fitting and matches the broadcast, so it doesn't look offset for the viewer at home.
Yeah, because generally that return path isn't making it to air. It's
Correct.
just
exactly that. It's just for monitoring, for either commentary monitoring or pitch side monitoring, wherever the presentation is happening from. Camera shading, of course, is a really interesting one as well, because shading happens particularly in the UK where we have weather like this, where the sun's coming in and going out rapidly, or take a venue that's well known, like Wembley Stadium, for example, in the middle of summer. The FA Cup happened at the weekend. Wembley is notorious for being a challenging environment for shading, because it has a very big shade line at 3 o'clock in the afternoon, half across the pitch, and particularly on the tighter cameras, which are chasing player close-ups and things in and out of the light. They need to be shaded really quickly, otherwise you're very quickly going to lose control. And that might not be obvious on the live cut, because the director will probably paint over it, but it really does ruin replays, of which there are far more than the average viewer would notice. So consideration needs to be given about whether to shade locally or remotely. My experience is that decision is based on the use case. So football, in those kind of environments, people wouldn't traditionally try and shade that remotely. But if you're at an indoor arena, so for example, basketball, where the lighting conditions are forecast and predictable, or even a Champions League game in the evening where you're always under floodlight, and really good floodlight, so the conditions aren't going to change from 7 o'clock to 11 o'clock, you can get away with shading remotely because the lighting is so good. But really it comes down to that editorial choice and a sensible decision about the conditions that you're going to be faced with all the time. And in fact, shading on site isn't a massive talent challenge in terms of engineering resource, because you still have to have engineers on venue to put out cameras and monitors and plug things up. There's always the analog part, if you want, of production, which we can't avoid, and that still needs some on-site engineers. So it isn't necessarily adding huge overhead in terms of that requirement if it's needed.
And I guess thinking about the other closed loop things, that tally is another thing that's actually in that loop. So what's the criticality on that?
Yeah, tally needs to be fast, but of course it does create a slight interesting problem, which requires a bit of training, because the tally can go on in real time from the vision mixer timing plane, when in fact, of course, they'll cut up a shot that's happened a couple of seconds earlier, or maybe 1 second earlier. So there's a bit of care required there. Often a good director will become more vocal on a remote production with long latency contribution, because they're aware of that challenge, and will call cameras maybe more verbally than was traditionally become the norm with really good tally systems locally. But a good director will have done that previously and will be experienced in that, because I probably shouldn't admit to this, but tally systems can be some of the least reliable things that actually still, for whatever reason, still happen in production, and so directors are used to doing good calling. But on a low latency production, maybe just half a second, it's probably okay. It's the really long latency remote productions where you have to think a bit more about it and make sure that production have got that in their language.
Okay, so putting some figures on some of those latency loops. We've obviously talked about the local audio, which is uber tight. We've got various compression technologies which we're tending to use both in the outbound as well as the return path. Typically there's everything from the uncompressed, which if you've got unlimited budget or dark fiber or something you can get away with. Not many people are doing truly that. There's then JPEG XS, which from a compression perspective is the actual compression engine is sub-millisecond, even though you've then got buffering and stuff that goes around that. So, you're looking about route delay plus probably 10 milliseconds for buffering that's sitting there. And then you've got the temporal compression, the HEVC, the AVCs, which can tend to be many tens or even maybe a couple of hundred milliseconds or more, depending on the way they're implemented. What I know it's application dependent and event dependent, but can you bound some of those latency expectations that you think are viable?
Yeah, I mean, so if you look at what's happening right now in the market, there are well-established broadcasters in the UK who have got suitably big budgets, who have got uncompressed contribution networks running on a weekly basis. The Premier League is a good example of that, which is they enjoy a fantastic arrangement where they can bring back multiple cameras and sources in uncompressed 1080p 50 up to 1080p 50 back from each venue, which is amazing. Typically, we were originally, when I was working with BT Sport, we were using things like HX4, like you say, and maybe half a second latency. They've now been mostly migrated out to JPEG XS, so they're now down to probably 1 or 2 frames. I mean, actually, the bigger latency with JPEG XS deployment is actually all of the frame buffers and frame synchronizers that we're still putting in operationally. The Vision Mixer still operates a minimum 2 frame delay. There'll probably be a frame sync on the way in and the way out. So you're probably accruing, 4 or 5 or 6 frames. And at which point, interestingly, the contribution codecs become negligible in that overall time space. And then you get to longer latencies with things like cellular bonded remote production. So the sort of work we were doing with UEFA Youth League, which is an interesting tournament. It's a 6-camera tournament, but mirrors the Champions League. It's the under-21s teams playing at venues with no connectivity, and they'll use sort of cellular bonded backpacks because there's no other connectivity, and the error correction across those different routes through each of the different cell networks. But typically we'd be operating those at 1.2 seconds, so much longer latencies. But in fact, because we were doing all of the production add-on, things like graphics and commentary downstream in the production center, it didn't matter at all. And this is back to the point we were talking about earlier about comparative synchronicities. What really needs to be synchronous, and does it matter? So interesting use case there is that, as long as things like camera 1 and 2, which are the gantry shots, of camera 1 being the traditional wide angle of a football game, camera 2 being the shadowing tight shot, and in camera 3 the low center camera, as long as those are completely synchronous, so a director can cleanly cut live between them, it doesn't actually matter potentially whether things like the 18-yard cameras for offsides or replays, or the 6-yard camera behind the goal are slightly different latencies, either slightly slower or just mistimed perhaps, because the chances are they're going to be fed through replay anyway. So obviously a production team don't want them to be wildly different because it breaks things like logging and archive retrieval in the future. Ideally production teams want them pretty close, but an additional few frames here or there really isn't going to be a challenge for a live production team trying to tell a really good story around that game.
Yeah. One anecdote I remember is talking to some sports production gallery people about how like 1 or 2 frames was like really seen as an issue until they wanted to do augmented reality for VR sets and stuff, and suddenly they're prepared to tolerate maybe even half a second of latency for the privilege of being able to actually introduce that creative element. So when there's a key creative requirement, people will actually tolerate a lot more latency and even split the sound. So have people working on headphones and stuff just to make that work.
It's an excellent point, and COVID was the same, right? We'd been we've been encouraging and had been going on a remote production journey for a number of years. But when it became a necessity, it suddenly became a much a much easier sell to our production friends who on the benefits of that journey. But you're right,
Yeah.
AR production environments, they're not even listening in sound, mostly in vision galleries. So a production team, a director, and a producer, et cetera, all working together, have actually got no concept of AV sync, because the pictures on their monitors in front of them are not synchronous with the sound they're hearing out of the speakers, and they have to trust the sound department that what is being produced is excellent. So the tolerances absolutely can be made, to your point.
Yeah. In terms of implementation, I guess this is moving more towards the software world, but also looking at 2110 en route as well. Because one of the things that I think is frustrating, as we have introduced more and more technology, we've actually made inherent latency in the workflow bigger and bigger. So before we even got to SDI, you look at the analog coax network around London, it was intrinsically running at the speed of light in cable, because you didn't have any other way of doing stuff. And then we moved to SDI, and then we had the occasional frame sync. So the lines room always had frame syncs for inbound stuff. So you had a kind of frame delay there. But then when we moved from SDI to 2110, one of my bugbears on that is people are unwilling to take the risk of partial offsets like a traditional SDI based vision mixer. We'd got it down to, even with multiple stacked MEs, you could actually only incur maybe 3 or 4 video lines of latency. As soon as we went to a 2110 implementation, and most of the big video switching vendors do this, it jumps to a whole frame of latency, just because everyone's scared of people being able to cope with the partial offset. So everyone now is compensating to a frame latency. And then as we move to software implementations, I think I call, this is probably me being inflammatory here, but lazy implementations. The way you create reliability is to throw loads of buffering in. Because the more buffering you put in, the less risk there is of data running dry and all of this stuff. And I do feel we have some way to go back to reclaim sensible latencies in implementation of the different parts of the chain. Because if everyone throws a few frames of latency in the production, especially as we try to get back to more of a best of breed architecture, where people in the software world can choose their favorite vision switcher and their favorite graphics and their favorite XYZ, then suddenly, if everyone has de-risked everything with so much buffering, it can all build up. And I think we can improve that a lot, is my ambition.
I would agree. And look, we're moving now into a world where the next most important piece of R&D, I think, is the improvement of ground to cloud, right?
Yeah.
We talked, at Andy Beale in detail about GCCG and the work you're heading up in the Video Services Forum. I think for me that's really important. The principles are identical, right? The low latency return from the cloud for monitoring has to be super fast, low latent, and synchronous in the same way we were describing earlier for remote production in the classic sense, and the feeds going back to talent on venue. The control services have to be super responsive, and the monitoring has to be super quick. At the minute, what I'm not seeing coming as quickly as I think we should is improved high quality but low latency ground to cloud that is capable of being adjusted and adapted for the challenging worlds of outside production, where you have all sorts of different contribution networks and service providers. And I think that's a really important part, and I agree with you, would require real focus to really unlock and make those technologies more and more useful and enable us to do better storytelling, basically, in those environments.
Cool. Wonderful. Hey, well, thank you for your time. It's always good to have a conversation, and it's always good to share some of this thinking with people. Are there any other key points that we should actually cover before we
Well, we didn't talk about one of the problems that we used to encounter a lot and put a lot of work into was timing not wavering once you've got a set.
Okay, the stability of time
The stability
as
of timing playing is actually more important. I talked already about it's important that things like camera 1, 2, and 3 are completely synchronous, but we're not so fussed if cameras, 18-yard cameras, are potentially a little bit hit or miss in terms of. But what is really really difficult and is a massive problem is if the timing plane changes. So once you've got set up and you've lined up, variability of that latency is a massive problem, because then you lose sync, because you'll have timed in your microphones, you'll have timed in your ball kicks, you'll have timed in your cameras together, and if that starts to vary or adjust, then you've got a big problem.
Yeah. I think that's also true, isn't it, for the operators? That
Correct.
I think the operators can get used to a certain latency of operation from button press to transition, but if that changes, that experience changes. That's actually all bets are off then.
Absolutely, yeah, completely agree.
Cool. Wonderful. Hey, thank you very much for your time. It's always good to talk. I'd love to have another conversation, maybe on the use of ultra high resolution moving forward and what's really important to the end user. But we can have, we'll tee that up, and maybe in a few months' time have another conversation on that one.
That'd be
Anyway, I
great.
look forward to hosting you for a proper peppermint cup of tea at some point when you're over this way. Thank you as always for your time, and
No, pleasure.
it's good to chat.
Yeah,
Thank you.
brilliant.
And ladies and gentlemen, Mr. Andy Beale, thank you very much. And join us next month when we'll have another conversation about something else. Thank you.